All right, we're going into lesson 1.3, which is about how energy gets transferred to the air. So, if air is getting warmer or cooler, we know that there's a change in energy. So, first, we have a warm up with a graph showing the temperatures during El Nino years versus normal years. So, in a normal year, the average temperature in New Zealand is 12 degrees Celsius, but in an El Nino year, it is 11 degrees Celsius. So, our warm up question says the graph above shows the average temperature of New Zealand during normal years and during an El Nino year. The graph tells us that it is slightly cooler during El Nino years, which means the air has blank energy. Is it going to have more energy or less energy when it is cooler? The answer here should be less energy. So today we have an investigation question that we're going to be exploring. And that question, question 19, I want you to write in, how does air get energy? So when we warm up or have a warm day, where does that energy come from? Question 20 is a vocabulary term, transfer. Energy has to be transferred to the air in order for it to warm up, or it has to be transferred out of the air in order for the air to cool down. So, what does transfer mean? It means to move from one object to another or from one place to another. So, write this in for question 20. So, when we ask how air gets its energy, we are really asking about energy transfer. We want to know how energy is transferred to the air. Today, we're going to look at two claims about how it happens. Let's look at two diagrams representing the claims. So, here we're on question 21. Question 21 in your notes. There's a claim 1, explanation. Claim 2, explanation. So, there are two possible claims or answers to the air gets its energy from. Write these two claims down below and bold the one that you think is correct. Then, for each claim, explain why you think it is correct or incorrect. So, what are our two possible claims? First one, claim 1. Energy is transferred from the sun to the air. So the air heats up directly from the sun because the sunlight's passing through the air. Claim 2. Energy is transferred from the sun to the surface and then to the air. So the sun heats the surface up and then it heats the air. So write these two claims down, bold the one you think is true, and then explain why you think claim 1 is true or false. Explain why you think claim 2 is true or false. All right, question 22. We are going to actually test out our experiment. So, we have an experiment to gather evidence to help us determine which claim is more convincing. This experiment models the natural world. So, we're going to have a heating lamp. Then the lamp will be half over land, half over air. The land is going to be represented by some rocks. The air is going to be represented by no surface. And the lamp represents energy from the sun. So we will use 2 cups to trap a small amount of air and measure the temperature in 2 locations. Air with no surface underneath and air above some rocks. So you see here there's cups with thermometers in it. I'm going to jump over here so I can see myself. We got cups with thermometers in it. Like this. So we're going to measure the temperature in both locations 2 times, once at the start with the lamp off, then we'll turn the lamp on, wait for 20 minutes so it can thoroughly heat the land and the air, and then we're going to measure the temperature again. Remember in science, we record the air temperature in Celsius instead of Fahrenheit. We're going to try to determine how the air gets its energy by comparing the air temperature before and after we turn on the light in both of these locations. So here, what evidence, after we do this experiment, what evidence would support claim 1, that energy is transferred from the sun to the air? And what evidence would support claim 2, that energy is transferred from the sun to the surface and then to the air? So, what our experiment is going to look like. Let me switch to this screen. I know my thing is here small. I don't know if I can make it bigger. Doesn't look like it. Okay, So we've got this heat lamp here, and down on the desk, we've got, oops, that's hard to do. We've got two little sticks. Oh man. Here, let me just move the whole computer. Okay, we've got two little sticks and some rocks, and above it, a heat lamp. So to start off, we're going to just place our cup with the thermometer over the rocks. The lamp is off currently. Might be kind of hard to push these down. You might have to tilt some of the rocks. There, now it's over there. And we have our cup over the empty air off the table. So first of all, you get an initial reading in Celsius of these two thermometers, and then take them off and set them aside. Then we turn on our heat lamp and let it sit there for 20 minutes. So this heat lamp should heat up the rocks and it should heat up the air, and we're going to see which one heats up more. Set a 20-minute timer, and then after 20 minutes, you come back, put these over there, and we'll measure the temperature and see which section is warmer. Okay. While you're waiting the 20 minutes, go ahead and proceed to the next instructional video and continue doing some sim activities, and then come back here to get your data after your 20-minute timer goes off.